Next, we move on to visualization. So we begin this by importing matplotlib as PLT and importing Seaborn as SNS. Then we do figax plot to subplots, fig size 15 to 16. Basically, this sets the figure size to 15 inches width by 6 inches height. Then we do colors is equal to blue all the way to gray. Basically, this defines like a list of like distinct color for plotting the multiple stocks, such as like stock 1 all the way to stock 5. Then we have for I call enumerant df.columns, axis plot df index df.call label equal to call, line width is equal to 0.5, colors is equal to colors brackets I module length colors. So basically what this block of code does, it basically this iterates throughout each of the stocks in like the column in the data frame and plots its price over time as like a separate color on the same chart, with like each of its each unique stock getting its own unique color from the colors list over here. Then we move on to setting it, giving it a title, stocks price over time, the date for the x-axis and y and price for the y-axis, and then we plot over here. So here's our visualization for the stock prices over time. So basically, stock 4, which is this yellow colored stock over here, shows the most strong upward growth, as it's like the highest one out of all these stocks, as compared to stock 2, which is red over here, which has like a negative downward trend, declining from like around like 100 all the way down to like it's like 65. So yeah. Next, we move on to returns distribution analysis for all those stocks. So stocks num stocks is equal to len stocks df.columns, and fig is equal to plt figure fig size 18 and 10. Basically, what we're doing here is num stocks counts like how many stocks we're like analyzing, and then fig over here basically creates like a large figure size of 18 by 10 for like visualization. Next, we do gs is equal to fig add grid spec to num stocks height equals ratios 1 to 1. H space is 0.4, W space is 0.3. Basically what this line of code does is it creates like a sophisticated like 2-row layout with dynamic columns. Then we have colors is equal to blue all the way to gray. This defines like a list of like distinct colors for like plotting like the multiple stocks. Then we do return data is equal to empty brackets. Basically this stores like the calculator returns for each of the stock, and then summarize stats is equal to empty brackets. Basically this collects the statistical metrics for later like analysis for each of the stocks. Then we move on to for I call enumerant df.columns. Returns is equal to df.columns.pt change.drop na. Returns data as brackets call is equal to returns. Basically this calculates like the return for each of the stocks. Then we move on to axis equal to fig add subplot of gs from 0 to I. Basically creates like an individual stock plot for each of like the stock's returns. Then we do nbin patches is equal to ax histogram with these parameters. Basically this plots like the histogram with custom colors for each of the stocks. Then we move on to giving the title, so returns distribution, the x-axis, and the y labels for frequency. Then we move on to mean red is equal to returns mean all the way to max return is equal to return max. Basically, this adds like a statistics as like a text box for each of the stocks. Then we have mean red is equal to return means all the way to max red is equal to return max. Basically, this calculates like the mean returns, standard returns, and minimum returns and maximum return for each of the stocks. And then we have stats tax is equal to mean returns all the way to like b block dictionary. Box style is equal to round pad 0.3, face color is white, alpha is 0.8. Basically this like adds the statistics over here as like a text box for each of like the stocks. Then we have summary stats append all from stocks all the way to like volatility. Basically this stores like the statistical measures for each of the stocks. Then we have x combined is equal to fig add subplot gs 1 all the way to ax combined grid true alpha is 0.3. Basically what this block of code does is it adds like a combined comparison plot in like the bottom row, and this creates like an overlay like histogram showing like all the stocks at the same time. Then we move on to import warning with warning catch warning warning filter warning with ignore message. Basically, ignore messages figure include access that are not compatible with the type layout. Basically, this handles like matplotlib warning for like complex grid layout. Then afterwards we plot this, plot all the stocks and their return distribution. So here's a visualization for this. So stock one's return distribution has like a roughly normal distribution centered around 0, while stock 2 return distribution has a slightly wider distribution and it's like more negatively skewed as over here, and while stock 3 has a very narrow and tight narrow distribution, as majority of it is like around 0. As majority of the returns is very clustered around 0. Then stock 4's return distribution has like the most widest distribution and has more spread out in terms like of its daily returns. Then we have stock 5, which is like relatively has like a modern distribution. So here we have all the combined return distribution for all the stocks. So overall, the green has like the highest daily return, followed up by like red and yellow following on. So yeah. Next we move on to data processing and cleaning. So target stock is equal to stock 1. So we have focused on predicting stock 1 in this example as it has like the closest one to like a normal distribution. Then we move on to data is equal to df brackets target stock dot copy data dot columns equal to price. Basically this creates like a working data frame. Then we move on to data is equal to data.drop NA. Basically just removes any of like missing values in the data set. And then data equal data sort index. Basically this sorts by day, which ensures like chronological order. Then we print out the clean dataset shape by data.shape, the data range, data index.min, data index.max, and then we print out the first 5 rows by using data.head. So target stock for distribution as before is stock 1 because it has the most normal distribution. Clean dataset shape is like 365 rows with 1 column. Data ranges from 2020 01 all the way to 2020 12 30. And here we have like the first 5 rows of the data set.